Welcome to the project demonstration of battery management system along with thermal protection with the help of DS18B20 temperature sensor. So which is the waterproof sensor, temperature sensor, which will continuously getting the temperature with high precision, nothing but 0.1 degree precision it will provide that, and the same details continuously measured by the microcontroller. So in this project the main features are we are going to continuously measure the voltage and current and temperature, these three major parameters in EV vehicles for maintaining the battery life effectively. So we need to monitor continuously these three parameters: voltage of this battery pack, so whether it is drastically discharged or overcharged, and the current also, if the load was on the battery is more than the threshold value or not, and the temperature. So while we applying the charging voltage or else while we applying the load, in these two cases we need to continuously monitor the temperature of the battery pack so that we can protect the battery from fire protection, that is nothing but thermal protection of a battery pack. So these are the three major features are executing in this model, and to achieve these features we are making use of sensors like temperature sensor, that is DS18B20, and voltage sensor. From this is a voltage sensor. From this we are going to measuring the voltage of the battery pack, and this one is the current sensor, which is used to measure the current of this battery pack when we on the EV vehicle. So we are representing this DC motor as electrical vehicle. Coming to the ratings, so we are using 12 volt 1 amp battery. So this battery pack consists of three 4 volt 1 amp batteries. They are in series, so we'll get 12 volt 1 amp DC output. That is the main operating voltage to this load. So we are using 1000 rpm 12 volt DC motor we are using, and continuously these parameters measured by the PIC microcontroller with help of these sensors and displaying the same data on the 16:2 LCD screen. And also we are using the two control buttons, and they are used to on and off the charging circuit in the normal charging and fast charging. So these two are switches are connected to the microcontroller, and also whenever the battery voltage is low, then the system will provide us the audible alert through the buzzer, as well as whenever the temperature crosses the 50 degrees centigrade, then also we'll get the audible alert. In the same manner, to control the temperature of this battery pack for suppression purpose, we are using this DC fan. So automatically the fan will be controlled whenever the temperature crosses the 50 degrees centigrade. So to execute all these features, the major components: power supply, 230 volts AC input to the transformer, and which will be stepped on the 230 volts AC to 12 volts of AC. The 12 volts AC input to this regulated power supply board. From there the AC 12 volts will be converted into two outputs. One is 12 volts DC with help of rectifier and filter, the 12 volts of DC input to the battery pack through these charging relays. And the next, the operating voltage of our microcontroller is 5 volts of DC. For that purpose we kept 7805 regulator, which will take 12 volts DC inputs and provide us a 5 volts DC output. So when we provide the 5 volts DC output to this microcontroller motherboard, so in this one, this is the main microcontroller, and on this motherboard remaining two major components are there. This is a reset switch to restart the microcontroller. It just only restart the microcontroller, it won't erase the program. And this steel plated one is a crystal oscillator to provide the clock pulse to the microcontroller. So once it got the 5 volts power supply, it start reading input from the temperature sensor, voltage sensor, and current sensor. So we have interfaced them: A0 for the current sensor, A1 for the voltage sensor, and A4 for this temperature sensor. Based on these three sensors inputs, as well as C0, C1 for the selection of the fast and slow charging. So these are the 5 inputs. Based on this, system will control output modules like relays based on the selection switch, buzzer based on the voltage level and temperature levels, and the fan based on the temperature level. To control the fan, we are making use of this transistor board. On this we have the BC547 transistor, which will act as a switch to control this fan. And LCD display interface at pin number B2 to B7, and we have interface the C6, C7 for this relays, and C3 for the buzzer, C4 for this fan or transistor board. So these are the main input output connections of our project. Then once we can on the power supply, there we get the welcome message on the LCD screen, right? So after welcome to the BMS message, there we can get the continuously voltage, current. As of now the load got switched off, that's why the current is 0 here, and temperature is 35.1 is normal temperature. So whenever voltage is low, so in order to make the voltage low, so we set the voltage level is 8 volts. So whenever the battery pack voltage is less than 8 volts, then the system will provide the audible alert to make inform to the user about to charge the battery pack. So for that purpose, we are using this switch to just isolate the power supply to the voltage sensor, so that the voltage is 0. Now the buzzer is on and provides audible and visual alert. So then the user can select the switches for normal charging and fast charging purpose. So it will take around 2 to 3 hours to be get fully charged if the battery voltage is less than 8 volts. So once it reaches, so the system doesn't know about the switch, but it just checking the voltage to this voltage sensor. So if the voltage is sufficient, that will be measured and displayed on the LCD screen. Coming to the current also same, just we using this switch here on and off the motor. So motor is rotating now and the same current measured and displaying on the LCD. So I is the current 1120 milliamps, that is nearby 1 amp of current and off, right. And coming to the temperature, so whenever the temperature of this battery pack is more than the threshold value, as we discussed, so we set the threshold value of 50 degrees centigrade. So when it crosses 50 degrees, then automatically, so you can see that the fan got switched off. So till it's coming to normal, the fan in on state only. So when it's below 50 degrees centigrade, again it will be normal and buzzer along with fan will be off. Right. Fan will be off and buzzer will be off. So here the main advantage and application of this project is in electrical vehicles, we should monitor continuously the battery voltage, current and temperature. In that the temperature is a major role to protect the battery from fire accidents. Thank you.